has no base, okay? It has no base whatsoever, okay? Now, what that means is it's completely rounded the entire time. So there's no flat surface on a sphere, okay? A sphere is like a ball, right? So like a basketball. Okay? It's like just basically like a circle on all edges, right? What else could be like a sphere? Like the sun. The sun is a sphere. The earth, yep. What else would be a sphere? A tennis ball. Yeah, a volleyball. Okay? A bowling ball, okay? All of these are spheres. They're completely rounded on every side, so they have no base whatsoever, all right? By definition, a sphere is the set of all points in space equidistant from a given point, okay? So essentially, right, we have our center of a sphere. Any point on the edge of this sphere is all the same distance. What's the distance between a point on the edge of this sphere and going all the way to the center? What is that distance? It's a radius, okay? So all of these that we draw are radii, okay? As long as they go from the center to any edge on the sphere. So it's the same distance regardless of where you are on the sphere to that center, okay? Now, do you guys remember when we were dealing with circles, when we would draw a line, like the one seen above, where it would go from one edge of the circle to the other edge of the circle? We used to call that a chord. It's also labeled a chord in a sphere, okay? And then going from one edge of the circle to the other, but going through the center, we still call that a diameter, okay? All right, and what do you guys think is going on in the last picture? It's being split into two, exactly half, okay? So this cross section, right, is exactly through the middle of the sphere, and that creates what we call a great circle, okay? And exactly half of the circle is up here, and half of the circle is down here, and we call that a hemisphere, okay? A hemisphere. Correct. Yep. So exactly half of it is a hemisphere. All right. Now, a hemisphere would not be like a smaller section of the sphere like this. Okay. It has to be exactly half of it. All right. That cross section goes directly through the middle of the circle, right? It includes the center of the circle. You guys got that? Okay. The surface area of a sphere is the formula. S is equal to 4 times pi times the radius squared. 4 times pi times the radius squared. Where R, obviously, is the radius of the sphere. Okay? Does that look similar to anything?
Yeah. No. R squared. It's like the... But why is it 4?
It's like what, Jaden?
Why is it 4?
Very good. It's like the formula to use to find the surface area of a circle, or the area of a circle, right? The area of a circle was what formula? Pi r squared, okay? Now I'm going to be honest with you guys. I don't know why you can just multiply it by 4 and that gives you the surface area of a sphere, okay? But it just does, okay? But the area of a circle is pi r squared. The surface area of a sphere is 4 pi r squared. Okay? The surface area of a sphere? The area of a sphere. So area and surface area, the difference between them, if you find the area of something, it's a flat object. So like if you were to find the area of a rectangle, right, it's flat. Surface area is any three-dimensional figure. You're still finding the area of it, but you're finding the area around it. Does that make sense? Okay. Okay, so the volume of a sphere is 4 over 3 pi r cubed. What's that? You would just do 4 divided by 3 and then use that answer to multiply by pi and then the radius cubed. Okay? Or you could do 4 times pi and then times r times r times r and then divide the whole thing by 3. What? You wouldn't have a variable. You'd be given r, right? That makes sense? What's that? So at the end of this lesson, I'm going to okay? So the volume of a sphere is 4 over 3 pi r cubed, okay? All right. So complete the table for spheres. Leave your answers in terms of pi, okay? So the first one, it says the diameter is 12. What would the radius be? 6, okay? If we know that the radius is 6, what would the surface area be, okay? Let's just, for reference, guys, let's write that formula up at the top. So remember, the surface area of a sphere is going to be 4 times pi r squared. So let's plug that into our calculator. Let's do 4 times pi times the radius squared, so times 6 squared. What'd you guys get? Very good. It's 452.4. Okay. And then what units is that going to be? Or whatever units it is. So let's just put units. But what dimension is it? Squared. Very good. Okay, because it's area. You guys cool with that? Okay. Now for volume. Please write the volume formula at the top. Your volume is going to be 4 over 3 pi r cubed, okay? Where your radius is 6. So this one's very important that you guys figure out what's the way that you want to plug it into your calculator, right? I have students that multiply 4 pi and 6 3 times and then divide the whole thing by 3. They do 4 divided by 3 in their calculator. They use that answer and they multiply it by pi. And then they multiply it by 6 cubed. However you want to do it, just make sure. Yes, you just put the caret pointing up, and then you can put a 3. So this one should be 904.8 units cubed. Did you guys get 904.8? Please, guys, you guys should absolutely be plugging this into your calculator right now because this is really good practice. Did we all get that?
How do you do the 3?
How do you do the 3?
Yeah.
Divide by 3.
No, like
Oh, cubed?
Yeah.
Yeah. So do you have a caret button?
Caret.
Yes. Okay. So, guys, so for the next one, we're given the radius. What would the diameter be if our radius was 7? It would be 14, okay? So let's fill in the 14. What would be the surface area of our radius was 7? Let's use the formula. Gabby, what'd you get? 615.8. I got the same thing, 615.8. And we're just, units squared, okay? And then our volume, let's use the same radius. So 4 over 3 times pi times the radius, which is 7 raised to the 3rd, 1,436.8 units, what? Cubed, okay, because it's volume. Guys, please, 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 I cannot stress how important it is that you guys get the calculator practice and make sure that you're getting the same numbers I am, okay? Are we good up to here?
Yeah.
All right. For the next one, okay? 3,200, we put the, do you guys agree, is still in the same spot, right? So we're dividing by 3. So 4 pi r cubed, well, 4r cubed is what this gives me. 4r cubed. So we're going to say 4r cubed is equal to 32,000. Because the pi and the 3 are already there. okay? So we're just saying 4r cubed is equal to 32,000. How could we solve this for the radius? Zoe, what would you do? Excellent. Divide by 4. So let's do 32,000 divided by 4. You should get that it's 8,000. And then what could we do?
Square root.
Ah,
No, because it's cubed.
it's cubed. So instead of the square root, we take what's called the cubed root, okay? So you're going to take the cubed root of both sides, okay? Now, in your calculator, okay, there's two ways you can do that. You can take 8,000, and do you remember that caret button? You can use that caret button, but instead of raising it to the third power, you're going to raise it to the 1/3 power. And you should get 20. So you should have r equals 20, okay? Now I'm going to walk you through that on your calculators. So I'm going to pause the video. What was our radius again? 20, okay? So our radius is 20. Our surface area, if we plug in 20, we should get 4 times pi times 20 squared. 5,026.5 units squared. And our diameter would be 40, okay? All right, if our surface area was 12 pi, we would set that equal to 4 pi r squared. We're going to divide by 4 pi, divide by 4 pi. These pi's are going to cancel. 12 divided by 4 is 3. So our radius squared is equal to 3. We would take the square root. So the square root of 3 is going to give me 1.7. So my radius is 1.7. My diameter then would be 3.4. And my volume, when I plug in 1.7, is 4 divided by 3 times pi times 1.7 to the third power. And we should get that our volume is 20.6 units cubed. If our radius is left in terms of r, we would just write 2r for the diameter, because we multiply our radius by 2 to get the diameter. Our surface area would be the same formula, so 4 pi r squared. Our volume would be 4/3 pi r cubed.
You would just leave it.
Yep. Now, let's say our radius was 2r. R was a bad variable to use, okay? You could think about it as x. Our diameter would be what? 4r. And our surface area would be 4 pi times 2r squared. And our volume would be 4/3 times pi times 2r cubed.
So you don't solve it?
No.
You just
Not for this one. Area of a sphere is the same as the number of cubic centimeters in the volume of a sphere. Find the radius of the sphere, okay? So what that means is the surface area is equal to what? The volume, okay? So what was the formula for surface area, guys? 4 pi r squared is equal to
cubed.
pi r cubed. Very good. Okay. So we have to solve this and figure out, okay, what's the radius that makes the surface area of a sphere equivalent to the volume of a sphere? Okay. What would you guys try to do to solve this? Remember, we're solving for r. Xavier, what would you do?
You can cancel out the pi,
Good.
and then also when you move the variable to one side, on the right side just becomes r.
Okay, hold on. I love what you're saying, okay, but let's take it one step at a time. Cancel out the pi's, very good. We can divide everything by pi. What do we have after we do that, Xavier?
4r squared and 4/3 r cubed.
Very good, okay? 4r squared equals 4 over 3r cubed. And you said do what?
You divide by r squared.
Very good.
And then turn into 4 equals 4/3 r.
Okay, so we divide by r squared. R cubed divided by r squared. Do you guys agree that r cubed is r times r times r? And if we divided by r squared, which is r times r, how many r's would cancel? Two of them, right? So how many would we have left over? One. So we're just going to have r over here. So we have 4 equals 4 over 3 times r. You guys cool with that? Okay, now there's one extra thing that we need to do to solve for r. Does anyone know what to do? Bingo. Multiply by the reciprocal. What's the reciprocal here? 3 over 4. So if we multiply by 3 over 4, the 3's cancel out, the 4's cancel out. What happens to the left side? Not 4. Zoe? It becomes 12 over 4, right? Because we can multiply it across. 12 over 4, which is 3. So 3 is equal to r. Now watch. You could have just canceled out what when you multiplied by 3 over 4? The 4's. Do you guys see that? The 4's could have canceled out and you would have gotten 3. Or you could just multiply straight across and get 12 over 4. Yeah, Zoe?
Could you also just multiply 3 and cancel out the 3 on the bottom and then divide by 4?
Yes. You could take it one step at a time and multiply the entire thing by 3 and then divide the whole thing by 4. Okay? So our radius is 3. So when you have a sphere where the radius is 3 units, okay, its volume is the same as its surface area, okay? That is the only sphere with exactly 3 units where the volume is the same as the surface area. Okay? All right. One more. We're almost there, guys. Okay, example 3. A solid consists of a hemisphere of radius 1 meter on top of a cone with the same radius and height, 5 meters. Find the volume of the solid, okay? So this is a composite solid, right? Because it's 2 shapes. What's one of the shapes? A cone, okay? So we're going to write, we have a cone down here. And the other shape? Hemisphere. Okay, so remember the volume for a sphere was what? For a sphere. It was 4/3 pi r cubed. Do we have a sphere here? Hemisphere. What do you think we do to this formula? Divide it by 2, okay? The volume for a cone. We just covered this yesterday. What is the volume for a cone? 1/3 pi r squared times the height. Okay? Why did I divide by 2? Guys, why did I divide the volume of a sphere by 2? It's a hemisphere. It's exactly half of a sphere. Do you see that? It's like an ice cream cone, right? Part of that cone, or part of the ice cream is inside the cone, so we don't include it. Okay? All right. So, what's the radius of both the cone and the hemisphere? It's 1. So r is equal to 1. What does that 5 represent? That's the height of the cone, right? So h equals 5, all right? And we have everything to solve, okay? So let's find the volume of the sphere first. Let's go ahead and do 4/3 pi, our radius is 1 squared, over 2. We plug that into our calculators. Times pi. 1 squared is just 1, and then we divide it by 2. You should get 2.1. What units am I in, guys? Meters cubed. And then lastly, we do the cone. So we've got 1/3 times pi times our radius squared. Oh, did I not? Guys, I made a little mistake. Instead of writing squared, I should write cubed up here. Do you see when I found the volume of the sphere? It's cubed, guys. Sorry. And then multiply it by the height. The height is 5, okay? So this should have been 1/3 times pi. And then times 5. 5.2. Which one's my answer? You add them, so you should get that your volume of the whole solid is what? 7.3 meters cubed. That's it. Turn